Hi, my name is Ruth Yakubu, and welcome to this Train the Trainer for Azure Machine Learning Prompt Flow. In this Train the Trainer, I'll be walking through the different materials that the trainees of this workshop will need in order to set up the participants to understand what the context around that. I'll also be covering tips and tricks. This workshop is intended to be 1 hour, 45 minutes to 1 hour long. So I'll try to rush through well, not rush, but cover all the information within the given time. So to start with, I have a PowerPoint that I encourage all the instructors to utilize before they start the lab. And also, most importantly, it's very important since time is of essence to try and cover this PowerPoint section for 15 minutes. So the very first slide that you're seeing here is for the Train the Trainer. What you do is for each facilitator of the Train the Trainer, just replace the avatar with your profile image and also your name, your title, your affiliation, and any social media handles that you want the audience or the participants to get a hold of you. So that's the very first thing. So one thing I suggest is as people are going through, as you're going to be going through these steps, one of the lab component steps that the participants are going to be going through is using Azure Code Spaces. And it takes about 10 minutes for Azure Code Spaces. So what I recommend for you is have everybody go to this workshop and kick off the Azure Code Spaces. So this is the web page for the workshop. And for the workshop that we're going to be focused on today is the Azure Machine Learning Prompt Flow. So the users can go to the, click on the workshops tag and select Azure Prompt Flow. So when they go to Azure Prompt Flow, they're going to be going through the portal version. So what they need to do is click on Lab 1. And when they click on Lab 1, what they need to do is open the project in GitHub Code Spaces. So all they need to do is click on this button, and what they need to do is click on create a new code spaces. So they can click on that button, create code space, and that will kick off the Azure Code Spaces. Like I mentioned, this takes a while. So to make use of the lab, I'll suggest everybody kick this off. No questions, then return back to the PowerPoint to proceed. Once they go through the lab and launch the Azure Code Spaces, the next thing they need, you need to go through what we're going to cover today. So we're going to go through prompt engineering, understanding what it is. Then getting into Azure Prompt Flow, the features it has, and why should we care, or what the benefits are. Then we're going to go through an example of a flow evaluation, talk a little bit about what that entails. Then lastly, we'll get into the lab. So it's very crucial to stress this point to the end users, since there are different communities and audiences taking this workshop. Depending on what the audience is, make sure you point out that each participant needs to have an Azure subscription. That's the very first thing. But the second thing that's very important is they need to have the Azure OpenAI service enabled in their Azure subscription. So if they don't have Azure OpenAI, they're not going to be able to complete this workshop. Let's talk about the state of AI today, what we're seeing. So in today's data-driven world, demand for AI system to be less harmful to individuals and society is very important. And ethical principles have never been more pronounced. So to give you an example is just with OpenAI, generative AI in the past year, we're seeing rapid pace of AI solutions or innovations being developed. So that's the number one trend that we're seeing. We're also seeing a lot of organizations and even individuals trying to allocate a lot of investments to adopt AI into their everyday processes. So if it's a business, how can they incorporate AI in their internal business processes to make employees' tasks a little more efficient so they can concentrate on more important tasks that are out there. Sometimes it's also incorporating AI to get a competitive edge. Another thing that we're seeing is there's an increase in societal expectation when it comes to AI. We're seeing more people participating in discussions around AI, and there's a lot of excitement, but there's also a lot of scrutiny that we need to pause and have regulations around AI. Then lastly, with a lot of these concerns around AI, the governments are also responding to come up with processes, frameworks, and new regulations on how to regulate AI as a response. So the very first thing is what is prompt engineering? Since we're going to be dealing with prompt flow, the question is, what is prompt engineering? So when we talk about prompt engineering is a concept of natural language processing that involves embedding descriptions of tasks and inputs to prompts the model will utilize to produce outputs that are desirable based upon what the input is. To take a step further in understanding what prompt engineering is typically includes a problem description. So when we say a problem description is basically defining what this AI system is supposed to do. So the scope around what this AI system does. Then the next thing is instructions on how to solve the problem. So you are going to see a lot of rules in terms of how the prompt or the system should perform when they're engaging, let's say, with the end user. So the tone, should it be polite? The do's and don'ts that the prompt should follow. And also sometimes it also includes examples of certain use cases. If they come across certain use cases, how to go about solving that or correcting that problem or inquiry that the user presents. As we talk about prompt engineering, as we deal with LLMs, one of the popular things that I'm sure you've heard about is dealing with vectors. So the question is, what are vectors? And also embedding. You're also going to hear a lot about vector embeddings. What does all of that mean? In this particular workshop that you're going to be working with, you are going to be dealing with the situation where you're bringing your own data and storing it in a vector database. Then we'll be using the LLMs and using the prompts to tell it to get its information or provide responses that is only grounded or tied to the information that is stored in our vector database. So the very first thing, the process of vectorization and embedding is first you have text that you present to the system. So let's say you have your CVS file with your data. You upload it. The very first thing is converting it into a numerical representation. So each word, depending on what the embedding model that you have, in our case, we're dealing with text embedding, ADA-002 out of Azure OpenAI. And that embedding has a huge dictionary of words or a corpus of words. And basically every single word is linked to a unique number. So the word in this example, her dress is a prom dress. If you notice, dress appears twice. Dress is mapped to the same number. So that's how it works. It's almost like, like I mentioned, a dictionary. Each word is assigned a numerical value. So the question is, where does the embedding come from? So you have the OpenAI model that is able to create embeddings. So it takes the numeric value and finds similarities and relationships in the words and groups them into vectors. So if you look at one vector, the vector will contain numeric representation of different texts, but the common denominator is they all have a meaning and they all have some kind of relationship and similarity in the grouping. So to give you a picture of how the relationship will look like is, let's say there's a word capital that is inserted. The next thing is, okay, capital has, depending on what the context is, has multiple meaning. Could be you're talking about, when you're talking about capital, you mean capital letters. It could be when you're talking about capital, it means capital punishment or crime. When you're talking about capital, it could be related to finances, like tax, money, investment, capital gains, finance. When you're talking about capital, it may be a location, so maybe a province, state, building, or a country. So as you can see, the relationship, depending on where the groupings are, this is what embedding does in the background. So another thing to keep in mind is in this lab, you are going to insert data into the vector database. So the question is, as you're going through the steps, why are we doing embeddings? So basically, the input data that you bring in, it's going to go through this vectorization and embedding. So it's going to convert all the text into numerical representation, then add vector embeddings. So it's grouping it depending on the meaning and storing into the vector database. The next thing is also creating indexes or indices, one of those. But when the indexes are created, basically when somebody is doing a search, it's going to be going to find the right match. You'll go by the nearest neighbor scoring. So later on, let's say you went through all the steps, you brought your data, you stored it into the vector database. Everything is in numerical representation. So now that you have your AI system, that the user is entering text input that is going to query that database, they're bringing in text, but you can't really query text against numbers. So what you need to do is use the same embedding model that you use to embed the input data, the data that you stored in the database. That's number one. So you use that vector embedding model to convert the text into a numeric value and also find its vector embeddings. So once you have in vector embeddings, that's when you do a query search or a vector index lookup to find, depending on what the question is, the LLM has natural language understanding and meaning of what the question is and where to go and find the best answer that matches what the search is for. So that's basically when we go through the lab, this is what is going on. So let's come back to Azure Machine Learning Prompt Flow. So usually when we're dealing with prompt flow, we're doing everything, let's say in a notebook. Everything is you're dealing with code, like Python code. It's challenging to do everything via code, especially when you're defining your prompts, especially when you have a workflow of different tasks that you need to go through, maybe defining what your prompts are, what your, let's say, OpenAI model to use, when to use embeddings, and also when you're querying the data or the model that you want, how to integrate the LLM with the instructions and the prompts and the user inquiry. So the good thing is what Prompt Flow does is it gives you the ability to create all of these workflows using various large language models or language model APIs. You can also use different data sources, or you can use the existing pre-trained LLMs out there to get information depending on your use case. You can also design, construct, tune, and evaluate, and also test your LLM workflows on a very large scale. So when we're dealing with LLMs, it's dealing with a lot of data. So depending on what the use case is, what Prompt Flow offers to the users is different templates depending on what the use case that you are dealing with. on how to go about and evaluate the performance of your model to see whether it is reliable and it is giving accurate information or output. So we talked about evaluating the workflow with pre-built metrics. Another good thing is it makes it easy for prompt tuning. So as you're creating your prompts, you can easily look at the prompts and refine your prompts. The next thing is you may have one prompt, but as you're tuning your prompts, you're trying to figure out, okay, let me try this prompt and see how well your model demonstrates. Or let me create another prompt, another variation of the prompt, and tweak it a little bit and see how the model behaves. So all of those actions that you would normally take programmatically, the prompt flow does all of that in a very easy to follow and intuitive graphical representation or user interface. Another thing is there's a shift in addressing responsible AI and the different metrics that we use to evaluate models when we're dealing with building AI solution. So the very first thing is, yes, you are, when you're dealing with traditional machine learning models, the audience is usually machine learning engineers and data scientists. You have a model, you have data, you have environments and features that you're working with. When it comes to performance metrics, you're looking at things like accuracy, building the model, you have data and you're building everything from scratch. Now in the world of LLMs, things are slightly different. The audience, you're still dealing with machine learning engineers. We're also dealing with app developers that can easily create AI solutions using LLMs. You hear of everyday people creating ChatGPT solutions to do incredible things. The things that they're using is, okay, they're probably using LLM model like, let's say Azure OpenAI or the OpenAI API. They're using agents, you're using plugins. They're using prompts a lot based upon what they want to do. They're using chains depending on how they want the flow of the dialogue to be. And they're using APIs depending on where, what information, the additional information that they need to get from different resources that are out there. Things that have changed is metrics, because when it comes to LLMs, we're dealing with pre-built models. These are built on tons of data, billions of data, and some of the models are also fine-tuned. So on top of the pre-trained, you also bring your data and utilize a pre-trained to also train your model on that. So you have like a refined, fine-tuned based upon what your use case is to expand the pre-trained model. But the problem is kind of like how I mentioned before, when you're dealing with OpenAI or LLM, generative AI, the responses are dynamic. They're not always the same. So that is something, a challenge. The next thing is, in some cases, especially when you have a pre-trained model, you don't have control of the data. You don't know where the data came from, even though it is providing the solution, the responses that you need. So to evaluate this, you need more things. You need to test for accuracy. You need to test for fairness. You need to test for groundedness. So groundedness, we'll get into details later. You have to check on relevance. Is the answer that this, let's say, ChatGPT is giving me, is it relevant to what the question was, or the context of the conversation, the dialogue that I was having with the chatbot, or how coherent is it? As you're also dealing with the chat history and the context, okay, is it even making sense based upon what the subject matter is at hand? So these are the some of the things that have changed. And when it comes to responsible AI, producing models that are not harmful and trustworthy, the metrics have changed a little bit. So let's get into a more deep dive of the capabilities of the Azure Prompt Flow. When it comes to development, it gives you the ability to develop flows that connect to different language models and external data sources, or you could have your own custom code out there. The good thing is you can even integrate with Python. So in that flow, as you're going through the flow, manipulating the data, you also may need to bring in Python to add a little more logic or pre-processing before it goes to another step. You have the ability to test and evaluate. So you can run multiple tests in parallel. You can choose different metrics that you want to evaluate based upon the use case that you're dealing with. We also mentioned prompt tuning. So you have the ability to easily create prompts and have different variations of it. And the good thing is you can compare the results of the different variants and choose the ones that you think is more accurate based upon your use case. The next thing is it has a very good way of you to seamlessly integrate your pre-built LLMs. So similar to the Azure OpenAI, it is a pre-built AI solution, and it is the API that comes with a key and endpoint. So you can easily integrate that connection in there. You can also have your own custom APIs out there that you want to integrate in this process. You can easily go in the connections and add those. And this includes managing your credentials, your secrets, and also connections to any Python tools that you have out there. The next thing about prompt engineering, when you're using Prompt Flow, the very first thing you need to think about is groundedness. So one of the things you can do is give it documents or data sources, tell it to use those data sources. You can add do's and don'ts. You can use keywords like you must do X, Y, and Z. Those are ways to control where your data comes from. So when we talk about grounding, we just are talking about, okay, we want the information to come from this data source. We want to provide factual information and also relevant information. The next thing is hallucination. How can we control hallucination? So hallucination is basically when you have a response that is false and not factual. The crafty thing about hallucination is the data may come in a very detailed format that sounds factual. It may even provide references, but the problem is still not factual. So one of the things to do to curb that is include instructions of requesting the model not to make up stuff. So just plain say, hey, if you don't know something, say you don't know it. Restrict the output. So you can choose from a confined list of resources or targets that it should get its information from. You can add chain of thought style of instructions. So you can give it steps on how to go about providing an answer when it's prompted with a question. You can repeat most of the important instructions. So that's to emphasize the importance of it to follow and enforce the rule that you want. And also another tip is position the most important instructions at the end. So as is going through and reading your instructions, the most important ones are fresh towards the end. So that's about ensuring responsible AI for it to not give information that's not correct, that could potentially, somebody can potentially use that incorrect information and it could cause some harm. So here are some of the problems with having no groundedness and hallucination. So kind of like how we mentioned, when we're talking about groundedness, it needs to be factual and relevant to a given data source. So let's say you are dealing with a dental clinic. You can easily ask OpenAI information and they can provide information, general dental information. But let's say you have your own dental clinic that you just opened last month and people need or patients need to find more details about your clinic. If they ask things like, what is the address of, let's say, Contoso Dental Clinic, this is a specific clinic. OpenAI may not have that information. So that's one of the reasons why you need to provide your data source so it provides the right, accurate information pertaining to your unique clinic. Another thing is you may have a brilliant chatbot that users are coming in and finding information or getting recommendations on their. So let's say somebody comes in and is asking questions like, okay, which stock should I invest in? That has nothing to do with the business at hand. So in situations like that, you should flag that even if it gives a factual answer, that's still incorrect because you're dealing the scope or the relevance needs to be around the dental office and not giving out financial advice. Another thing is, okay, somebody may come in and ask, what is a root canal? So these are opportunities of providing factual and relevant information to the scope of your data. When we're talking about hallucinating, on the other end is providing false information that appears factual. So Here's an example of a cat that looks like a peacock. So let's say somebody comes in and asks, what are descendants of peacock? It's easy for maybe an OpenAI system to give an answer like cats are descendants of peacocks, and also provide reference of where they got the information and the page. This information could be incorrect, and also blatantly this is also incorrect. So this is an example of hallucination that you want to prevent. Then lastly, similar to how I mentioned early, Prompt Flow has the mechanism for evaluation. So you're able to evaluate your model as you create your flow, and be able to check for its accuracy, its reliability, its fairness, that sort of thing, or relevance, depending on the different use case. So there are a lot of templates out there that you can choose. And you can also build your own custom evaluation, how you want it to evaluate your flow that you just created. The good thing is you can also test bulk as well. So this leads us to the exercise. So now that we're done with the PowerPoint, the next thing is to get into the actual lab. So similar to how I specified initially, when you come into the lab, you're going to select Azure Prompt Flow, and we're working with a portal version. And the very first thing that we did before we started the PowerPoint is actually go to GitHub code spaces into the Azure subscription. So you're going to get a sign-in message like this. So and a code. So you basically need to copy the code in order to sign into the Azure account. So you click on the URL and paste the code and click on next. So I had to pause the video in order to provide my credentials. But after you go through those steps, it's going to ask for your email. It's going to ask you to provide your username and password, and do a multi-factor authentication. Once it's done, you're going to get a screen like this. And once you close it and come back to the command prompt, it should be able to log you in. Okay. So after you logged in, you were returned to prompt, and it should have showed your subscription. I had to pause the video so it doesn't show the personal information. But the next step, after you close the URL browser, after it did the multi-factor authentication, was for you to paste this and basically copy the ID of your subscription. So after you logged in, you should have seen a field called ID. Basically, you copy that number and paste it here. That's your subscription ID, and press enter. And it's gonna set everything that we do here to connect to that particular Azure subscription, just in case you have multiple subscriptions that you're tied to. So the next thing we need to do is create Azure resource group. So in my case, I already have a resource group, but basically what you'll need to do is provide something like, let's say, US. So you provide the region that is closer to you, and you give it a name. So you give it, for me, I'm going to, it's minute. So you give it a unique name for your resource group. So let's say 1, 2, 3. And I'll say RG for resource group. Some of you are gonna be wondering, okay, I don't know the closest location close to me. So one tip you can use is run this code, and basically what it does is it's gonna list all the different locations out there, all the Azure regions, and what you do is find the region that is closer to you. In my case, it was, since I'm in New York, I chose East US. So yeah, you copy the location and utilize that when you're creating your resource group. After you create your resource group, the next thing you need to do is set the default of your resource group into this environment. So all the scripts that you're running, you don't need to specify which resource group it should go to, because it already knows the resource group that you're dealing with. So I'm going to use 2023, should be 2024. So I'm going to utilize my resource group, set it as environment default resource group to use within this environment. The next thing is you need to create the different resources that you need for this lab. So basically what you do is copy that and hit run. So what we're using is we're using Azure Bicep template in order to create this resources. So it is an interactive script. So the very first thing it's asking is for the Azure OpenAI name. So I'm going to give it a name. So you need to provide it a unique name for your comfort. So let's see. Demo. Okay, so I gave it my Azure OpenAI name. The next thing is you need to provide the Azure content safety name. So I'm giving it AZ-content, I'll call it filter, name, and name. Okay. Next thing it asks is for the deployment of your GPT 3.5 Turbo model. So I'm going to give it GPT, just what it is, 35 Turbo. Then it also requests for the model deployment of the embeddings. So I'm going to give it text embedding, ADA, and the version is 002. The next thing is I'm going to give it, is asking for Azure machine learning name. So let's see. Give it Azure MLWS. Then for the workshop, I'm going to give it RAI work job. Okay. Then the last thing you need to do is select the location. So for me, since I'm in East US 2, I'm going to select 7 and hit enter. So once you hit enter, what it's going to do is Bicep is going to go through and create all these resources for you automatically. So you won't have to go through all of that process manually. Okay, so this is a very good learning. It did provide an error, but this is good because just in case you use a target name that is already taken, you are going to get an error. So the best thing to do in situations like this, if any of the users got any errors, be sure to look at the field and figure out which area the issue came from. So it looks like it does not like my machine learning name. Maybe that was taken before. So I'm going to come back and start again. Okay, so I'm going to give it a name for the Azure Open AI. So try Azure Open AI, and I'll give my initial. And let's do the same for content safety, but I'm going to call it safety. Instead of safety, I'll call it filter and demo. For the GPT model deployment, I'm going to give it a name, GPT 35 Turbo. And for the model deployment for the embedding, I'm going to call it text embedding ADA 002. Okay, so for the machine learning name, I'm just gonna give it AZML and use my initial. Then for the workshop, I'm gonna give it a name, just workshop. And for the location, I'm gonna give it 7 since I'm in East US. That's the location, and make sure it's the same location. When you're picking from the numbers here, making sure it's the same as where your resource group is deployed to. Okay, so the script has completed running. So we're going to go on to the next step. The next step is basically to set the environment variables that our script is going to need to run successfully. So we're going to run bash setup environment. So basically, as you can see, what it's doing is going and grabbing the OpenAI key, OpenAI endpoint, and so on and so forth, because these are fields that we'll need or values that we'll need for our script. So we need to set it in the environment variable. So the next thing we can do now that we're done with lab 1, we can move on to lab 2. So that's in the folder face ML index. So we're going to open that Python notebook file. The next thing is we need to set the environment, Python environment that we created. So we're going to be using py38 environment. So select that as your kernel selection. The next thing we need to do is we need the config.json file. This is going to contain information to connect to our Azure environment. So to do that, we're going to go to this hyperlink that says Azure ML Studio. Click on it. Okay. So we'll open the Azure Machine Learning Studio. In the instruction, it asks you to go to the top right-hand side of your subscription and click on the arrow down to download the config file. But as you can see, when we come to the portal, the resource group that I created is not there. If you see your resource group, go ahead and select it. But in my case, I'm going to go to click on View Resource Groups, and I am going to select the resource group that I created for this lab. So let's wait for it to open. So now it's open the Machine Learning Studio for the instance that the machine learning instance that I created. So to download the config.json file, basically you need to go to the upper right-hand side, click on this downward arrow, and you're gonna click on download. And basically what you need to do is right-click on source and select upload. And I'm going to go to downloads, where the location where it was download, to select the config.json file. But since there was another one, as you can see, it renamed my selection. So what I'm going to do is remove that one. So after you download, you should see a config.json file. In the file, it contains your subscription ID. It also contains your resource group, and also contains your Azure machine learning instance name. So once you have the config file downloaded and you selected your kernel, and run all. Click on run all. And basically what the script is doing is, the very first thing is doing is trying to authenticate to your Azure Machine Learning workspace. So kind of like how I mentioned, the config, and is using the config file. So the config file contains your subscription ID, your resource group, and your workspace name. The next thing is, if you're bringing in your data, as we're doing for Contoso, the Contoso Dental Clinic, we're specifying the location where the data is located. The next thing is we're storing the data as the data set in the Azure Machine Learning Studio. So that's the one thing that's good about the Azure Machine Learning Studio. You can put all your data that you're utilizing in the data set and register in the data store. And even if you're running other, experiments, you'll be able to reference that. You don't always have to create that. The next thing is we're also storing the test data for our Contoso data, that Contoso use case for when we get to evaluating the flow in Prompt Flow. You may ask, okay, why are we doing this twice? You need to pay attention that for the evaluation, the types of files that it support is .json, ML, or .csv files or .tsv files. So when you're using the test data, the data type is going to be different. The rest is going through and creating a compute, is also going through and creating a connection. So remember the different connections that we mentioned earlier is doing that, creating a connection for your prompt flow. After that, it's going to first look if you already have an existing connection. If not, it's going to create that connection for you. The next thing is doing is actually grabbing the model, your embeddings model that we talked about initially. Since you're bringing in data, it needs a model that does embedding on your text for the vector embedding, since we're going to store into the vector database. So this is what all of these steps are, and it's going to be using our text embedding information for that. So this script takes about 10 minutes to run. So I'm going to pause the video. Script to finish. One thing you can do to monitor is you can click on this link and it'll lead you to the Azure Machine Learning Studio. And this is how you're going to be monitoring the job that I just submit. So now that the job has successfully complete running, one of the first things you see that all the different components would turn green, which is a good sign. We're going to go to data, and we're going to go to dental face ML index. Click on that. This is the index, vectorized index that it created. What you need here is to click on the data source URL and store it somewhere. And this concludes Lab 2. So in Lab 3, we're actually finally going to get to Azure Prompt Flow and start creating flows and engaging with the prompts. The very first thing you need to verify before you do anything is make sure your prompt flow is enabled. So number one, you should be able to see prompt flow here. But just in case it's not, you can click on the bullhorn icon and go to easily run prompt flow without worrying about compute and runtime life cycles. If this is not enabled, go ahead and enable that. That should enable prompt flow for you. So now that that is enabled, we're going to get started on creating the different prompts. So let's get back to prompt flow. When we ran our script, it did create a connection for prompt flow. So within the script, it named it Azure -OpenAI connection. You need to click on that, click on edit. And what you're going to be doing is selecting what your subscription is, and also the name of your OpenAI instance that you created. Once you populate that, everything else leave the way it is and click on save. The next thing we're going to do is create a runtime. So when we were running our script, part of the script, what it did was also create a compute. So the very first thing we need to do is verify that a compute instance was created. So it should be called prompt-compute. So that's good. That's the compute environment. We need to come back to prompt flow. Go to runtime and click on create. We're going to create a runtime environment. So I'm going to call it flow runtime. You can give it any name that you want. We don't need to specify the description, but we need to select the compute. So remember the compute that we just that was created within the Python notebook. It is running, so just select that. Under custom application, leave it as new. Under environments, leave it as use default. So it's going to use the default prompt flow environment, so we don't have to create that from scratch. Click on create, then confirm. Now that our runtime environment is ready and running, we are now complete. We have completed lab number 3. So we can move on to lab number 4. So in lab number 4, the very first thing we are going to do is, let's get back to our machine learning studio. We're going to click on prompt. So we're ready to create a flow for a chatbot. So the very first thing we do is click on the create button. What the Azure Gallery does is provide different templates of different chats or different flows that you can utilize to play around with. So you can clone it or create one from scratch. For our use case, we're going to call it dental. I'm going to click on chat flow and call it dental chatbot. Okay, not bots, bot. And I'm going to click on create. So once it loads the canvas for the flow, one thing you're going to notice is you have one section where the different sections of the nodes are. On the right-hand side, you see an input node. So that we're assuming that's a node that takes the user's input. You have the chat and you have the output. You click on the input. This is the input section for the node. And as you can see, it takes in a chat history and a question. The next thing, let's jump to output. Node is the output node. It takes, it has an answer, and it takes the output that is generated from the chat node. So now let's look at the chat node. If you look at the chat node, as you're creating all these different sections, you also notice the type of nodes they are. This is an LLM node. So for the chat, we need to connect to our connection to Azure OpenAI. So you click on this drop-down menu, select the connection. So once you select the connection that you added earlier, the next thing is you need to select the GPT, because we are using the GPT for chatting, for Chat GPT. The next thing you need to specify is it needs to engage with the user. So in the prompt section is already populated for us since we're using a template. You can expand on it, but let's use the one that they have. So basically, the system prompt message is straightforward. It says you are a helpful assistant. One thing that you also notice if you're wondering is, let's say we're having a chat dialogue going on. What what the flow does is it keeps the history of your chat. So all the Q&A going back and forth, it keeps it under history. So basically, what it's doing here is going through and iterating through history, extracting what the questions the user asked in the past, and what the assistants also provided as a response. So that's what's going on there. So the next thing is we're going through and we have things like questions. We also we need to utilize a history. Where is it going to find that information? So luckily for us, it already populated that. So for under question, if you click anywhere in the box, it shows that, okay, it is extracting the input question that the user entered, which is here in the, if I can scroll up, which is here in the input field. When we're looking for where to find the chat history, is saying it should go to the inputs and grab the input chat history. So if we go to the node, we'll see that the input node has that information. So what we're going to do is save this this chat, and we're going to see if it can respond to any of our questions. So what we're going to do is ask this chatbot what prompt engineering is. So to do that, click on the chat button and paste in the question, what is prompt engineering? When you click on that, so as you can see, it gives us a long description of what prompt engineering is. The next thing, we're going to say, my molar tooth is aching so bad. What could be the cause? So we're going to submit that. So the molar tooth in the back. So first, it gives us a disclaimer that it is not a dentist, but it also goes through and provides all the possible things that could be the cause of a toothache. Then finally, we're going to go a little more specific. We're going to ask it for the address because, okay, this tooth is aching so bad, I need to go to the dental hospital. So the question is, what is the dental hospital address? Little tongue-tied there. So as you can see, this is OpenAI chatbot. It's powered by OpenAI. It is using general information, so it's not able to provide specific information for a specific dental clinic that is chatting with. So it's unable to give me anything specific to the dental clinic that I thought I was chatting with. So the good thing about this lab is we're going to go and create it. So the next time we ask it for specific information, it's able to give us more specific answers. So that's the end of lab 4. Now we can move on to lab 5. So the very first thing we are going to do is we're going to go back to our chat and we're going to close this dialog box. we're going to go to more tools and add embeddings. So more tools, and we're going to add the embedding node. So I'm going to give it a name like embed underscore question and click add. So if you notice, it asks for input. So we're going to go and click in here and we're telling it use the OpenAI connection. Next thing is, okay, what embedding model do we want to embed the inputs? We're specifying that we want the OpenAI text embedding ADA -002 model deployment. The next thing is asking is, okay, what is the input? Where should I get the input? And we're telling it to go to the input node and click on question. So that's how you specify the embedding. The next thing is doing, and the reason why we're embedding the node is you're going to be providing information that is in text format. Remember how we, in the PowerPoint discussion, we mentioned that the actual vector database is actually storing vectorized representation of the data that you that you're storing in the vector database. It's in numeric format. So we also have to do the same thing. So that's why we're adding an embed node to convert the question into numeric vector embeddings. Okay, so now once we specify that the input is coming to this node, if you notice, the input automatically connected to the node that we just created. And now we need to actually do a vector search. So what I'm going to do is create a node. So select vector index lookup. Give it a name, search vector index. And I'm going to click on add. So for the add, the very first thing it's asking for is the path to where our vector is. So remember when we ran the notebook, after the job, we had the data source URI that we copied and saved. Now it's time to copy and paste it into the path. The next thing is, what is the query? What are we going to search in the vector index? So that's going to be the question. So we are going to give it the output. So we don't, even though we have the input question, we don't want to specify that. We want to specify the embeddings. Hang on. The embeddings question output, because we want the question that we submitted in text format that has been converted into numerical vector embeddings to be passed into the search. So it is going to be searching number to number. The next thing we are going to do is we're going to add a prompt. So we're going to go back and click on add prompt. So what, I'm going to give it a name, generate prompt. So for this, what we're basically doing is we want to give the prompt constraints until this add a system message specifying what this chat should do. So basically in the instructions, copy the prompt and just everything, all the text within the prompt and paste it in the text box. So basically it says you are an AI system designed to answer questions when presented with a scenario. You must reply with accuracy to inquiries. If there's ever a situation where you are unsure of an answer, simply respond, I do not know. So that's what the parameters that we're giving it, the constraints and the information we're telling it it should behave. So we want the context. So as we're going through the dialogue, we want to get the keep in mind of the context. We also want the chat history, and we want a history of the questions and answers. So one thing that's pretty, I'll say pretty brilliant about the prompt flow is once you create your prompts, you can click on this validate and parse input. So all of these are placeholders like context, question, chat history, all of those are placeholders. So however many placeholders that you enter in your prompt or your system messaging, you can go ahead and add it here. Once you click on validate, it automatically generates those fields so you can easily parse and map it to the course, what you wanted, what field or what input you want to pass it to. So for chat history always stays the same. So we're going to give it chat history. For context, we're going to give it the search output. And for question, we are going to give it the original question that was passed. So as you are paying attention to the graphical side of the nodes, as we're connecting all these fields, automatically it is updating in the different nodes. So the last thing we are going to do is we are going to now move the chat that's actually, I'll say, the user interface to the user, and we're going to move it below the prompt engineering. So remember, initially, we already had a prompt embedded into the chat that we initially created from the template. We have added our own prompt with more details. So we no longer need this one. All we want to do is grab the answer and present it to the user. So what we're going to do is create what's it called? A placeholder. You can give it any name. The beauty of it is, and if you notice, the prior prompts that were generated, as soon as you say validate and parse input, it's going to update, delete, override all of this and create a new prompt. And if you can notice, this prompt is exactly the same name. So what Prompt Flow does is it goes in there and grabs looks for the placeholders, puts this at fields, and now you can specify what the output is. So for the output, we're saying grab the output from the generate prompt node. So we'll specify that. And if you notice, that is now connected. One thing we need to also verify is our output. So our output, the answer is still linked to the chat node. So we're going to go ahead and save this graph. And to test this, we're going to click on the chat node. One thing about when you're dealing with these chats, be sure to clear the history and the context, because whatever conversation you're having before, the chat remembers, and it'll give you the next answer that is probably related to the conversation that you guys were having. So to do that, just click on this dialog icon to clear the session. And I also want to remove all of that. So now we're going to test our chat to see what answer it gives us. So the last time we asked for the address, it did not know, since it was just being powered by the general OpenAI API. So now that we have our data provided, let's try and see if it knows what the address of the dental hospital is. Perfect. So as you can see, it was able to give us now a more concise location. So it gives us the address of where the hospital is located. So that's exciting. Next, let's ask it another question that is specific. See whether it can give us, let's say, what is the clinic's phone number? And what you can also do is go to the GitHub repo and the spreadsheet where the data is located. You can also pull it up and find other questions that you can ask. So it was able to give me that information. The next thing is we're going to ask it for recommendation on which supplements are good for teeth. So as you can see, it gave us a very detailed list of good supplements or vitamins that are good for oral health, that are good for the teeth. One thing about groundedness is we're testing for factual information and relevant information, but also it needs to be actually based upon the data that we gave it. We specified that, okay, provide information to the end users from our data. So even though it provided factual information, this is a responsible AI violation because it could be this information, if somebody takes it without knowing, the physician knowing any health background about somebody, let's say somebody blindly took any of these vitamins and had a bad reaction or side effects or anything, that's a negative consequence on the clinic. So this is causing harm to the end user. So these are reasons why we need to be careful on the information that is provided. If you check in the data that we provided in the spreadsheet, none of this information is there, whether it's accurate or not. So what we're going to do is we're going to fix this by modifying the prompt that we created. So as you can tell, the variant that when we were creating the prompt, for the most part, it was providing answers that we liked. So let's generate another variant of our prompt and give it more instructions and see how it can behave, how it behaves. So to do this, you click on Generate Variants. It's going to bring up this pane. All you need to do is update your connection. So provide the OpenAI connection that you had, and also provide the GPT model deployment name, and click Submit. So what we're trying to do is, this is basically what prompt engineering is. We're trying to manipulate the different prompts to see the optimum answer that we can get. So it did create a new variant, only that we can't see it. So to show the different variants is you click on Show Variant. Always remember that variant 1 was the initial prompt that you entered. But if you scroll down, variant 0 was the one that you initially created. Variant 1 is the new one that is generated. And another awesome thing about Prompt Flow is when you generate a variant, it will automatically try and generate another variant of your prompt. But in our case, we have specific rules. So we're going to go ahead and copy this text and paste it in here. Okay. So we're changing the prompt a little bit, but also one thing that is good to do is you may want to also click on Generate and parse input, just in case you have new fields. But in our case, we don't. But the new instructions that we're giving this chatbot is, you are an AI dentist assistant designed to answer questions. I need you to generate a response to the user question based only on context and information from the dental documents. So those are the documents we uploaded in the vector database. You must only, and we are emphasizing you must only in asterisks. So you must only provide responses from the vector dental documents. So we're telling it only provide responses that come from the dental document from the vector database that we have created. I want a well-formed and polite response. Please provide a unique, honest, and relevant answer. If you're not sure about an answer, kindly respond with the "I don't know." So this is a new variant that we're also providing the system. So we are restricting it to only use the vector document, but we're also specifying that it should use a friendly tone. So now that we have that, the next thing is the first variant of the prompt that you had is set as default. So what we're going to do is we're going to change it, the variant 1, to set as default. So we're going to change it to set as default. So basically, when we run this chat bot again, it is not going to run the other prompt, but it's going to run this new variant. So what we're going to do is click on the chat and the icon for the dialogue to clear the session. So after you provided, created the new variant and provided the new instructions, make sure you click on set as default, make sure everything is saved. And once you save that, make sure you go through and clear the history. So it doesn't have a history of the prior, what's it called? The prior context and chat history. So go ahead and delete all the session dialogue. And I'm going to copy and paste the question. So which supplements are good for teeth? I'm going to submit that. And let's see what the response is. So the good thing is it was able to say, I do not know, because we specifically told it to only use data that we uploaded into the vector database. So this is this is an example of how to enforce groundedness when you're dealing with large language models and also manipulating your prompts. That should have been the conclusion of lab 5. So we're going to go to the final lab. So for the final lab, what we're going to do is we're going to evaluate this whole flow in a bulk manner. So instead of going through like in the last lab and testing whether or not for use cases where maybe there's an issue in the factualness or relevance of the data or incorrectness of the data, we're going to utilize the evaluation template. So to do that, let's get back to our flow. So before going into evaluation, we're going to need a field called context. So under output, we're going to create a field called context. We need this field for the evaluation field. And the good thing is context, the value of context is basically what the chat output is. To evaluate this flow, we're going to click on evaluate. We're going to select a node to run the variant. So we're going to click on that. We're going to click on generate variants. With the generate variant node, we have the option of selecting which variant we want to evaluate. But in our case, we're going to check both, all the variants that we have. But if you prefer one, you can do that. Next thing is when we were creating our vector, we did upload the test data for Contoso, and we stored that in a data set in the Azure Machine Learning Data Store. So this is a reference to what it was. This was the name of it. So we can select that. The next thing is we need to specify the chat history. So for the chat history, since it's a list and we're starting from fresh chat history, we just give it the open and close bracket. So basically open, close, bracket. For the question, we want to map it to the questions from our test data set. So that's what we need to map it to. And also when you upload this, you should be getting a snapshot of the data in that spreadsheet that was uploaded. For the type of the different templates that are available for evaluation, let's say you can evaluate your flow depending on the use case. If it's a classification type of use case, you can use classification accuracy evaluation. Or if you want to use different evaluations, you can do that. In our case, we did just test it in the last lab for groundedness, but if we want to do it in bulk, we can easily do that. Since we brought in our data and we used it in the vector database to train to be able to look up the answers, we're going to use the Q&A RAG evaluation. So all we need to do is click on that, then click on next. Even if you get an error notification here, it just means that there are some fields that you haven't populated. The very first thing, verify that your contoso test data is populated. Also, you need to specify for this flow, what metrics, what performance metrics do you want to evaluate your flow? So in our case, we want to use all these three metrics. So we want to in bulk test for groundedness, retrieval time, like retrieval of the vectors, and also the relevancy of the answers that the output is generating. Then for answer, we're going to use the answer that our flow generated. So is our flow correct? That sort of thing. For questions, of course, since it's not engaging with a real person, we're going to grab the question from our test data. Then for documents, we're going to use the context column that we just specify. So the context column is the one that's going to keep track of like the output of the flow. So once we specify that, we're going to click on next. We verify that we have everything here, but the thing is we also need to specify our connections. So what you need to do is under evaluation setting, just expand that. And as you scroll down, you see for the connection, there's a default connection, but you need to upload that to your connection. So let's make this into edit mode. And we're going to select our OpenAI connection that we created. And under model, the deployment model, we're going to use the GPT-35 Turbo. So we're going to go through all of that and make sure that's select. Once that's done, we're going to click on next to review the summary. So everything looks good. And we're going to click on submit. So once we click on this, it's going to go through the evaluation. And if you want to monitor the evaluation, what you can do is click on Prompt Flow, click on Runs, and it's going to show the status of the run. It's going to take about 20 minutes for the evaluation to complete. Okay, now it looks like all the runs have completed for the evaluation. So one thing that you're going to notice from the run outputs is it went ahead and ran the evaluation for both variant 0 and also variant 1. So to look at the details of what the results are, what you do is we're going to select the very first variant and see what the Q&A RAG evaluation results are. So to do that, you click on the radio button next to it, click on visualization. The good thing about Prompt Flow is the output for each and every, what's it called? Each and every test that was ran, you can see what the input question was and what the what the output was, and whether, and also the status, whether the test that was run passed or failed. So if you go through the records, you can see all of the data from our Contoso dental use case. You can also look at the status of the test, whether it completed or it failed. You can also look at the different metrics, so variance and whatnot. So if you notice, as you scroll through the different results, you're seeing 5 and let's see. Yeah, you're seeing 5. It looks like for this use case, we're seeing 5 or not available. But 5 is actually a good score. The scores for the evaluation range from 1 to 5. So 1 is the worst performance, and 5 is actually the best performance. So if you get a 5, that means for the metric for groundedness for that particular test, it looked like it had a very good performance. So that's one thing, going through the individual use cases. The next thing is for our data, we have 475 records in our data sets, in our test data set. So one thing you can also do is also look at the summary. It has a summary of the run. So you can see on average, when it comes to groundedness, it looks like we have a 5 for this version. Let's see, that's for variant 0. And the retrieval score is 4.99, which is good. And also the relevance of the output is also 4.92, which is really good. You can also see the token count that was utilized for this test. So this is how to go about when you're dealing with large language models, how to go about creating the flows, how Prompt Flow makes it easy for you to create the flow. And also, even though you're dealing with large language models, you have the ability to also test it and also test for things like groundedness, accuracy, and also hallucination, which has to do with responsible AI. Similar to how I mentioned early, you need outputs that are factual and not swaying the end user off that could potentially cause harm. So that concludes the lab for this workshop. Thank you.